Yes, guys. So today I'm taking questions, not questions. Still, let me take what are the circumcircle, what is the incircle, what is X circles or ascribed circles. Three kinds of things I'm going to discuss. And what is the orthocenter also, bisectors, okay, bisector of angle, etc. So first some geometrical concepts. After that, I'll take these. There are certain one or two questions I've taken here, but I'll take more questions based on the incircle, circumcenter, okay, circumcircle or circumcenter, based on circumcenter, what is circumcenter, what is the incircle or incenter as well, what are the X circles or ascribed circles. Let me first define them. Okay, after that, what all the geometrical concepts are very important for students who are appearing for engineering exams as well as for engineering students or geometrical students who are studying basically from geometrical background. Okay, so in case of trigonometry, here the trigonometrical concept which I have to discuss about. Okay, so these questions and questions when we have discussed about all these, I'll take some questions, a lot of questions are there because the students have asked me number of questions based on incircles, X circles, what are the circumcircles, what are the ascribed circles. Let me first define them. Okay, after that I'll take these questions and I've taken starting. First question is what are the circumcircle, what is the incircle and ascribed circles. Let me first define. And here I am taking circumcircle, incircle and X circles of a triangle. So first let me take question number 1, which I have written down here. What are the incircles? So what are the incircle I talk about? Incircle. Okay, what are the incircle? First I have taken circumcircle, okay, no problem. Incircle, circumcircle. What is the circumcircle? And ascribed circles or X circles. I have taken X circles, they are known as X circles or known as ascribed circles. Ascribed circles. Let me first define them completely. These three are very important questions. Based on these are many numerous questions are there. So I'll take some basic questions which are just defining all these concepts and questions based on them, how to calculate them, how to solve these questions. That is the point today. First, let me circumcircle. What is a circumcircle? Circumcircle. So how do we define that? Let me write here properly. This is circum, C-I-R-C-U-M, C-I-R-C-L-E, C-I-R-C-L-E, circumcircle. Okay, so what is circumcircle? If there is a triangle, let me tell you, if there is a triangle ABC, this is a triangle ABC, let me tell you, then the circumcircle is a circle passing through the vertices or angular points of a triangle. That is known as circumcircle. So let me define this. A circle passing through the angular points of a triangle. Let me write of a triangle ABC here. Let me take. Triangle can be any PQR ABC. I've just taken denomination as ABC. So this denomination is ABC. This is the triangle here. Then a circle passing through this. This is the circle here. Let me describe that circle. This is the circle which is passing through the angular point or the vertices of a triangle. This is circumcircle. So a circle passing through the angular points of a triangle or the vertices of a triangle, or passing through the vertices of a triangle. The vertices of a triangle is known as circumcircle. Is known as a circumcircle. circle is known as circum. Okay, its radius is denoted by capital R. We denote this radius, and its radius we denote by capital R. Okay, so radius of the circle, suppose there is a point here, okay, passing through all this. Let me take this point here, and this is the center of this. Okay, suppose this is a point. From this point, we have to find out this what is OB. Suppose this is O point, OB, OA, OC. This is known as radius of the circle. This radius we have to find out. That I'll describe later. But before, let me just describe that how this is calculated. So this is the radius here. This radius are calculated, but we denote this radius by capital R. That's the point. So radius of a circle. So this is known as circum radius, or radius of a circle is denoted by capital R. Okay, so what is the value of this? You have to remember, or one has to remember some formula based on this radius of the circle, and that I'll just note down those formulae. But before that, let me describe what are these ascribed circles and in circles. Then in circles, suppose let me take what is the in circle here, and take all the three together. What is that? In circle, circle, and ascribed circles or X circles. These three together are taken in one figure, or one triangle, or one polynomial. Let me take. Okay, so that polynomial having number of sides. Okay, not triangle, not a quadrilateral. Okay, not a pentagon, not hexagon, but okay, it may have n sides. If there is a figure or polynomial, if it is having not polynomial, but it is having a number of sides. Pentagon is having 5 sides, hexagon is having 6 sides, septagon is having 7 sides, etc. So any polygon, this one is polygon. Okay, so polygon is having many angles. So that figure, if it is having any circle, which is passing through all the angular points, all the vertices of that figure, that polygon is known as circum. And this radius is denoted by R. This is a bit information regarding circum. Now let me take what is in circle. What is it in circle now? Okay guys, so what is the in circle? Now in circle. What is in circle? Okay, it is a circle. It is a circle touching all the three sides. It is a circle described inside the circle and touching all the three sides of the circle. Touching all the three sides of a triangle. Let me take ABC. Inside the circle, inside the triangle. Okay, inside the triangle. Let me take triangle. Inside the triangle. Inside the triangle, if we draw a circle which is touching all the three sides. For example, if there is a triangle like this, okay, and if the circle is touching all these points, these are midpoints of the sides, or maybe we will just describe them. And what is the radius we will take? This is the in circle. Let me take this in circle like this. It is touching all the three sides of a triangle. This is known as in circle. Okay, this is suppose center of this, and the center from this, if we draw perpendicular, this is radius. This is the radius, and this is the radius. Okay, let me take again. This is O point here. Again, this is O point here, and this is a smaller r. We denote by small r. The small r is the radius of the circle. Then take A, B, C, D. A, B, C, D. Let me take this as P, O, P, Q, and R. Let me take Q here. Okay, so this A, B, C, P, Q. Let me take Q here. This is R. So P, Q, R. B, Q, R. Okay, so these are the points on the sides of the triangle, and the circle is touching these sides of the three sides of the triangle. Okay, then this is known as in circle. This is in circle here. In circle, touching all the sides inside the triangle. This is inside the triangle, so this is known as in circle. It is a circle touching all the three sides of the triangle inside the triangle, or it lies inside the triangle. Naturally, it will lie inside the triangle only, then it will touch the three sides. Otherwise, how one circle can touch all the three sides from outside? Cannot touch. But this can touch. In that way, we will describe them as ascribed triangles. Because in that situation, the two sides are extended. Okay, now ascribed triangle. This is known as in circle. So in circle, the radius of in circle, the radius of the in circle, the radius of the in circle is denoted by, we denote this, anybody can denote by any number, but we are denoting here, is denoted by small r. Small r we have denoted the radius of the in circle of the triangle. Now, question based on this we will draw. First, let me describe that how this small r is, what is the value of this small r, and how the capital R is denoted. What is the relation between small r and capital R? Describe all those formulae. Okay, and after describing these three types of figures, we start with three types of circles. Okay, then I'll talk about what are the formulae which are to be remembered by us just to solve the questions. After that, I have to prove those formulae, that how those formulae are obtained from these in circles, S circles or ascribed circles, and circumcircles. Okay, so what are those formulae, how they are obtained, and what are the values of them? Those values, first I'll note down all the formulae, and after that we will describe them, that what are the formulae, which are those formulae, and how those formulae are obtained. So this is in circle. Radius of the in circle is noted by small r. Capital R was used for circumcircle, radius of the circumcircle. This is in circle knowledge. Okay, now let's take what are the ascribed circles or X circles. Ascribed circles or X circles. Next is ascribed circles. Ascribed circles or X circles. They are known as X circles. X circles means they are touching the triangle from outside. Okay, outside of there, the circle is lying outside the triangle. The original triangle, whatever is there. Let me take this triangle like this. This is A, B, and C. We take B here, and this C here. Okay. Then what is the ascribed circle for this? Now, if I just take or extend this AB side further, and this AC side also further, like this, and we draw the bisectors of these angles, angle B and angle C, outside. There is a bisector of this angle and the angle C also. If I draw a bisector of this angle, this is the bisector of this angle. Okay, let me join this A to this point. If I take this as I, let me take I, no problem. Then, and this is the bisector, this is B by 2 angle. If I take B by 2, not a problem, because complete angle is B, and this angle is lying outside the angle B. So this is angle B here, this is angle C here, this is angle A, complete angle A. Okay, so if, then what is yeah, the point or the circle. Now the radius is taken for this triangle as. Okay, so if I take this radius, if I draw perpendicular from this point, okay, so let me take the perpendicular from I to the three sides. If I draw perpendicular, let me take perpendicular to this BC side. Let me take this is the perpendicular. This is B point. Let me take either this is the right angle or this right angle. Okay, no problem. And then perpendicular to the extended sides. And this is, let me take E here, because we take, this is the right angle, we have drawn the perpendicular to the extended sides of the triangle ABC. Extended side of the triangle ABC, let me take this is E point, ACE, okay, and this is F point, and this is right angle. Okay, so if we take, the radius is this is known as R1 here, we take this as radius R1, this is also R1, this is R1. So in this case, when we have taken A, the opposite side to A is BC, okay. So the side BC is being touched by the circle from outside. If we draw a circle like this, taking this radius, or ID, IF, IE as the radius R1, if I take the circle which is touching, okay, which is touching from outside, the triangle from outside, this is S squared circle. This is known as S squared circle, okay. If we take this is the S squared circle. Now there are three kinds of the circle. There are three types of circles. So this is in case when A has been taken, the angular point. The circle is opposite to the A angle. Okay, angle A. This is S squared circle with radius R1. B take. In case of B, if I take this B, if it is B, then A, B, C. We will take the triangle. Again, we will take this. Okay. I point, okay, from I point we have taken this angular points, I mean bisectors of these angles. Angle, let me take CBF. CBF is the, okay, this angle, and this IB is the bisector of angle CBF or FBC, and IC the bisector of angle DCE, right? DC, bisector of angle DC in this case. But if I take A, B, C, B opposite, then the radius will be taken as R2, R2, R2. Okay, the same kind of figure will be there, but this one S squared circle. So let me describe what is the S squared circle. So S, there are three circles in this way obtained. This is first circle we have obtained here. This is X circle or S squared circle. F circle or S squared circle here. F circle or S squared circle. First is X circle or S squared circle. F circle or S squared circle. Alright, what is this S squared circle in this case? If a circle, let me write here. If a circle is touching the side BC from the outer side, of it, side BC is opposite to the angle A, opposite to the angle A. Then this one ascribed center, ascribed circle center, ascribed circle center of the, then center of the, then center I, let me take in this case, or I1, if I take it as I1, I2, I3, etc. Let's center I1 of this ascribed circle, of this ascribed circle is obtained by joining the bisectors of the exterior angle of B, of the exterior angle, bisectors of the exterior angles B and angle C. Angles B and C, let me take angle B, angles B and C. The exterior angle of B and exterior angle of C, the bisector of those angles are joining together at I1. Okay. Then from I1 we draw perpendiculars to the sides BC, side this AC or AE. We can draw perpendicular AE, sorry, this I1E, which is joining the side AC extended at E. Similarly, I1F, which is joining the side AB extended at F. AF joining the side AB at F, extended AB at F. Okay, that is I1F, I1F, I1E, I1D. Here the radius R1, R2, R1 only. Exterior angles B and C from outside. So the circle is obtained by joining the bisectors. Then center I1 of this ascribed circle is obtained by joining the bisectors of the exterior angles B and C. Okay, at I1. So I1 we have taken here I1. This is I1. Then the radius of the circle, then the radius of this circle, then the radius R1, let me write upper. Okay, let me write here. In this case I'm writing here. Okay, in the above I'm writing this radius, then the radius, let me write here, radius R1 of the circle of this circle is obtained by drawing perpendiculars from I1. Let me take drawing perpendiculars I1D, I1E and I1F from I1 to, these are perpendicular from I1 to the sides BC, because I1D is on BC. This is B point here on BC. Then AC extended. Okay, I1E is on the side BC extended to E, and AB extended to F. So AB is extended to F. After that I1F and I1E is perpendicular on AC extended up to E. So that is the extended form. The radius is obtained this way. So this is the radius I1E, which is noted by R, and we denote this radius by R. We denote this radius by R1. Why R1? Because there are three radii, R1, R2, R3. Now R2 will be in case if I take, so this is R1 here in this case. Now if I take similarly, let me take similarly other two ascribed circles are obtained opposite to the angles B, angle B and angle C respectively. Okay, now if I take, let me take, this is A here, this is A. Now B is the angle opposite to which we have to obtain the triangle. Now in this case this will be A, B, C. I have taken here. Now A, B, C. Now opposite to B there is a side CA. From I1 we draw perpendicular. Let me take I1. This is I2 in this case. Center is now I2. Radius will be R2. We take now radius R2, R2, R2. Now this from I2 we draw perpendiculars again. This is A, B, C. Now this we have taken AF, no problem. And this is E again. E and F and D we have not changed. Only these angular points we have changed. Now we have taken B here, opposite to which we have to obtain the ascribed circle. Now this ascribed circle or X circle is obtained by drawing the circle opposite to this triangle, and this triangle is touching the three sides of the triangle. One side from outside this given side opposite to angle B. In this case CA side is touched by the circle at point D, okay, from opposite to B angle, and the sides, extended sides BC and BA up to E and BC up to F. At the point E and F the circle is touching. So, and what are these I2E, I1E, I1B, sorry, I2, this is I2D, is perpendicular to CA in this case. I2D is perpendicular to CA. I2E is perpendicular to BE or BA. BA. I2E is perpendicular to BA, which means BA extended at E. Similarly, I2F is perpendicular to BC. Is perpendicular to BC. So these are the perpendiculars here, and these radii are R2, R2, R2. We have noted R2 is the radii, or radius in this case. So this is the R2 radii. Okay, R2 radius. So R2 radius is the radius of the X circle or ascribed circle opposite to the angle B. Okay, now if we have taken this as angle, let me take angle C here, only this ABC will change. If I take this as C, then this is A, B and C. ABC, again this triangle, the circle obtained opposite to angle C. Now again it will have the radius 3, R3, this is R3, this is I3. I have taken the center. Okay, the center of the X circle or ascribed circle opposite the angle C, and this is I3D, I3E, I3F. Let me take, this is R3 radius, R3. Okay, so all these radii are radius. Radii means R1, R2, R3 are obtained in this way. We have described that how X circles or ascribed circles are obtained, and these I3 are R3, R3, R2, R1, how they are the radius of the X circles or ascribed circles. So these are the ascribed circles. I'll just denote that what are the values of this R1, R2, R3. Okay, they are obtained. I'll just first let me describe that what are these F circles. Okay, so all these S circles, in circles, F circles, in circles, and circumcircles have been defined or described. Now let me take what are the formulae based on these. Now those formulae are also very important. Now I'm noting down them. What are the formulae which will be obtained later on? For example, in question number 10, there is a formula. 11, 12, 13. These questions are describing the formulae. There are proof that how these formulae are obtained. What are those formulae? Important formulae. So important formulae which are to be noted down, which are to be remembered. Important. These are the important formulae or formulas. Important formulae or formulas. This is plural word. Formulas. Important formulae or formulas. For first formula, let me take X circle or sorry, circumcircle. This is circum radius. First is, let me take circumcircle. Circumcircle. For which radius is R, capital R, be denoted by capital R. This radius, the value of this radius is given by, first and foremost, formula is A upon sine A. We prove this. This is to be remembered. B upon sine B equal to C upon sine C, capital sine C, equal to twice R, capital R. Or from this, R is obtained as A upon 2 sine A or B upon 2 sines B equal to C upon 2 sine C. Okay, so either R equal to this or 2R equal to this. This is sine formula, which is equal to twice R we take, where R is the radius of the circumcircle. So this is circumcircle radius of the circumcircle. Okay, so this is capital R value. This is one of the formulae which we note down. So okay, questions based on this will be calculated later on, but before that let me note down the other formula, the next formula for R, which we will prove later on. But what is the formula? Second formula